Hello everyone and I welcome you all to today's video. In today's video, we are going to look how you are going to have a look at different statistical measure, and we are also going to look at some of the data engineering techniques for continuous or categorical data. We are going to understand these concepts by solving certain question of and some question paper. My name is Manas Pathak and I am a student of IIPS DAVV. So let's start. In the previous question, we saw how to calculate the logistic regression, how to apply the logistic regression using logistic function, and how to find the missing data values. The question for today is explain any four common features in the engineering techniques for continuous and categorical data for the data set 12, 15, 12, 18, 20, 15, 30. Compute mean, median, mode, and standard deviation. Explain when to use each measure. Min-max normalization. This technique rescales values to a fixed range, typically 0 to 1. It preserves the relationship between values proportionally. Minimum and maximum value from data is fetched and each value is replaced according to the following formula. So in min-max normalization, it uses the minimum and maximum values in our given data to normalize the data, and all the data is normalized. All the values are proportionally normalized with respect to each other. The formula for it is x normalized equals to x minus x min upon x max minus x min. Here x normalized refers to the normalized value of the data. X refers to the value of data which is not normalized. X min is the minimum value of the data feature x in our given data, and max corresponds to the maximum value corresponding to our data feature x. The minimum value maps to 0, the maximum value maps to 1. Other values are scaled proportionally. It is commonly used when fixed output scale is required. Z-score normalization. It is also known as zero mean normalization. This method transforms values based on mean and standard deviation. It is useful when the data must follow a normal distribution. So, contrary to min-max normalization, the z-score normalization performs the normalization of data using the standard deviation and the mean. The formula for it is given here. The formula is v dash equals to v minus a divided by sigma a. Here v is the original value, v dash is the normalized value, a refers to the mean of attribute a, and sigma a is the standard deviation of attribute a. This method centers the data around 0 with a standard deviation of 1. The values do not have any predefined range. So this is one more difference of z-score normalization with respect to min-max, where in min-max the data is strictly normalized to between ranges 0 and 1, whereas in z-score normalization the values do not have any predefined range. Now let's understand a variation of z-score normalization where we use mean squared deviation instead of standard deviation. Z-score normalization using mean absolute deviation (MAD) is a variation of standard Z-score technique. Instead of using the standard deviation to scale the data, it uses the mean absolute deviation. So in this technique, instead of using the standard deviation, we use the mean absolute deviation, which is nothing but the average of absolute deviations for each data point. This method is often used because it is more robust to outliers than the standard Z-score. Since the standard deviation squares the differences which exaggerates the extreme values, the mean absolute deviation, which just makes the takes the absolute difference, provides a more linear scaling that is less distorted by the extreme outliers. It is used when we require a stable scale. Here the mean is 0, but the standard deviation would be greater than 1. So using the mean squared error instead of mean squared deviation instead of standard deviation causes the standard deviation for the normalized data to be slightly greater than 1. Here is the formula for the z-score normalization using mean squared error. As you can see, it is the formula is similar to the formula used for the standard deviation, but in case of mean squared deviation, the denominator is used as mean squared deviation, whereas in the case of normal z-score normalization, which uses standard deviation, the denominator consists of the standard deviation. So the process of calculating z-score normalization using mean squared deviation is very simple. In the first step, we calculate the mean of the data. In the second step, we find the mean deviation, the absolute deviations for each data point around mean. In the third step, we find the mean of this absolute deviation, and then we put all the calculated values in the formula to get the answer. Here we are given this data. The data consists of three columns, which of the first is fruit. The fruit contains the discrete values. Then is the value of fruit, which contains the numerical value, and the price, which also contains the numerical value. So since the first column of fruit contains the non-numeric discrete values, we are going to apply the one-hot encoding to this column. So before that, let's first understand what one-hot encoding is. One-hot encoding is a method for converting categorical variables into a binary format. It creates a new column for each category, where 1 means category is present and 0 means it is not. The primary purpose of one-hot encoding is to ensure that categorical data can be effectively used in machine learning models. So the major reason for using one-hot encoding here is that most of the machine learning algorithms can only work on the numeric data. Therefore, to implement implement a machine learning algorithm on our data, which also contains the categorical variables, we will have to convert those categorical variables into a binary format, which is done by the one-hot encoding here, or any other numerical format, so that we can apply certain machine learning algorithms to it and process the data. Particularly about the one-hot encoding, in this method, if there are n number of values, n number of categorical values for my column, then I'll remove that categorical variable from my data and add n number of columns instead of it. So the number of columns in my data set increases by n minus 1, and then for each category, if that category is present in that row, then we'll indicate that by value 1, and all other category values, all other column values of category for that row would be 0, where 0 indicates that the category is not present in that row. Now let's solve this. Let's perform one-hot encoding for the given data. So now we have successfully performed the one-hot encoding here. Let me explain you how we have achieved it here. So for my given categorical variable fruit, I had three possible values, which were apple, mango, and orange. Therefore, I have removed the column of fruit and added three columns instead of it, which are named as apple, mango, and orange. So for each row which consists of the corresponding fruit in that column or in the row, would have the value for that category as 1, and all other columns would have the value 0. Hence, for the first row, since the fruit for it was apple, the value of apple column here is 1 for the first row, and mango and orange are 0. Similarly, we have performed encoding for all other columns, and we have successfully performed the one-hot encoding here. The main disadvantage of one-hot encoding is it adds several number of dimensions to your dataset, which could be costly in terms of processing of data and time to build the algorithm. Imputation methods: mean, median, and mode imputation. This method involves replacing missing values with the mean, median, or mode of the relevant variable. It's a simple approach, but it doesn't account for the relationships between variables. We use fill na df column dot measure method of pandas in Python to fill missing values of a column. Here df refers to the data frame, column refers to the column in which we have to imputate the mean, median or mode values, and measure is the statistical measure which could be mean, median or mode. Its pros are it's easy, fast, suitable for numeric variables, whereas its cons are it may distort the true distribution of the data. Third, interpolation techniques. Interpolation estimates missing values by using the trend or pattern of surrounding data points. It is more informative than simple imputation. So by here interpolation, we can use the regression techniques. It could be linear regression, multiple linear regression, or even the polynomial regression, depending upon our requirements for the interpolation. So basically the amount of data which we have apart from the missing data, it applies the regression techniques on that data and then estimates the value for the unknown data. We use interpolate method equals to method to fill the missing values using interpolation. In the method method parameter, we tell the program that which type of regression method interpolation technique we require to use, or we want the program to use. Its pros are it captures trends, preserves the relationships. Its cons are assumes a pattern, linear, quadratic, maybe complex. Now let's calculate the mean, median, mode and standard deviation for given data. Mean is the sum of all the values in the data set divided by the number of values in data set. Hence, the formula for mean would be sum of all values divided by total number of values. The sum of all values for the given data is 122 divided by total number of values 7. We get the value of mean as 17.43. Mean is used when data is evenly distributed, symmetric and has no extreme outliers. The mean is the most common measure for center, but it is highly sensitive to extreme values. So if there are several outlier values, or even if there are some of the outlier values in our data, then mean is very sensitive to it. So using the mean for our data set which contains outlier data will not be very useful, because it is very sensitive to outliers. It would give a biased, not exact result, and hence the approximation of the data, central tendency of the data would not be exact. So I hope you get that. Median. A median is a middle value for sorted data. The sorting of data can be done either in ascending order or in descending order. A median divides the data into two halves. So median is also known as 50th percentile because it divides the data into two equal halves of equal size. The median, since we are here we have odd number of values in our data set, the formula for median would be n plus 1 by 2th term of the sorted order. The sorted order could be ascending or descending order. Hence our median here is, since the value of n is 7, the value of our median would be 4. Hence we are going to have fourth term of the sorted order as median. Here we have the sorted order and its fourth term is 15. Hence our median is 15. We have to use median when our data is skewed or has significant outliers. The median finds the exact middle point, making it robust because it ignores the extreme values at the ends. So if our data is symmetric, then we use mean. If it is skewed, then we used median. Mode. A mode is the most frequent value or item of the data set. A data set can generally have one or more than one mode values. There is no mode for data set if every number appears only once. Mode is the most frequent mode. The formula for mode is the most frequent terms. Hence, the mode for our given data set is 12 and 15, which appear 2 times respectively. Mode is used when we are dealing with categorical data such as names, labels, or categories rather than just numbers. It tells you the most popular or common option. Standard deviation. Standard deviation is a statistical measure that describes how much variation or dispersion there is in data set or data points. It helps us in understand how spread out the values in data set are compared to the mean average. The formula for standard deviation is sum of differences between data points and mean, sum of squared differences between data points and mean divided by total number of observation minus 1, and we take the square root of whole value. So this is the formula, and these are the different variables in the formula. Now we perform the calculations. First we find the deviation of each data point around mean, and then we find the square of that deviation, the sum of which comes around 235.71. Then we put that value in the formula. First we calculate the S square, which is 235.71 divided by 7 minus 1, which is 6. The value of S square comes around 39.29. Taking the under root value for that, the value of standard deviation comes around 6.27. We use standard deviation when we want to know how consistent or volatile the data is. While the mean tells you the center, the standard deviation tells you how spread out the data points are from that center. So this was all about today's video. I hope you learned something from here. If yes, then consider liking this video and subscribing to my channel. I'll see you in next video. Thank you.